Good day everyone. Today we are going to start with part 6 electrochemistry, and we will be studying about batteries, which are the commercial cells in this part. So a battery will contain one or more than one electrochemical cells connected in a series, or it is a cell used as a source of electrical energy. It is basically a galvanic cell which converts the chemical energy of the redox reactions into electrical energy. For a battery to be of the practical use, it should be reasonably light and compact, and its voltage should not vary during its use. There are mainly two types of batteries. The first one is the primary battery, the second one is the secondary battery. So primary battery is a non-rechargeable battery. It is a device in which reactions occur only once, and after use, that is over a period of time, the battery becomes dead and cannot be reused. It produces electric current for a period of time, and with the period of time when no more chemicals remain available to take part in the reaction, the cell will not function anymore. So the most familiar examples, first one is the dry cell, also called the Leclanche cell. So it consists of a zinc container which acts as an anode, and the cathode is a carbon or the graphite rod surrounded by a mixture of powdered manganese dioxide and carbon. So the space between the electrodes is filled with moist paste of ammonium chloride with zinc chloride. This is an example of a dry cell. The reactions occurring at cathode are represented as follows. That is, MnO2 plus NH4 plus 1 electron will give rise to MnOH plus NH3. And at anode, Zn will become Zn2 plus and release 2 electrons. So here in the reaction involved at cathode, the manganese is reduced from plus 4 oxidation state to plus 3 oxidation state. NH3 produced in the reactions will form a complex with Zn2 plus to give ZnNH3 raised to the power 2 plus, and the cell potential is 0.5 volts, which is produced by this cell. Uses are there used in transistors and clocks. Next we'll be going to the mercury cell, second kind of primary batteries. So it consists of a zinc mercury amalgam as an anode, and the cathode is a paste of mercury oxide and carbon. And at cathode, the reactions will occur as follows. Here the reducing agent is zinc and oxidizing agent is mercury 2 oxide. Electrolyte will consist of a mixture of KOH and ZnO. So the reaction at cathode is HgO plus OH2O plus 2 electrons will give rise to Hg plus 2 OH negative. At anode, we have the amalgam plus 2 OH and which give rise to ZnO plus H2O plus 2 electrons. So the overall reaction will be as follows by adding these two reactions. And here the cell potential is approximately 1.35 volt, and it remains constant as in the overall cell reaction no ions are involved in a solution whose concentration can change during the lifespan of the cell. It is very long lasting, and the uses of mercury cell are they useful for low current appliances like hearing aids and watches. Now we'll be moving to the secondary batteries, which are rechargeable. So a secondary cell after one use can be recharged by passing current through it in the opposite way. A good secondary cell can undergo a large number of charging cycles and the reverse cycles as well. So the well-known example is a lead storage battery. So a lead storage battery consists of lead anode and a grid of lead packed with lead dioxide as cathode. A 38% solution of sulfuric acid acts as an electrolyte. When the battery is in use, then the cell reactions are: at cathode we have PbO2 plus SO4 2 negative plus 4H plus 2 electrons will give rise to PbSO4 plus 2H2. At anode we have Pb plus SO4 2 negative will give rise to PbSO4 plus 2 electrons. So by adding these two reactions we get the overall reaction to be Pb plus PbO2 plus H2O SO4 to give rise to PbSO4 plus 2H2O. So the potential of the battery is 2 times the number of cells present in it. So if we have a battery with 3 cells, then the potential will be 6 volt. And if we have a battery of 8 cells, then the potential will be 16 volt. During charging, the current greater than 12 volt is passed from the external source. Due to this, the reactions are forced to be reversed and PbSO4 on anode and cathode is converted into Pb and PbSO4 as PbO2 respectively. So it is used in automobiles and power inverters. Now we'll be moving to the second category of the secondary batteries, that is nickel cadmium battery. So it consists of a cadmium anode and a metal grid contained of nickel O2 as cathode. KOH solution is the electrolyte. So the reactions can be written as follows at the cathode and anode, and by adding these two reactions we get the overall reaction to be Cd plus 2 NiOOH plus H2O will give rise to NiOH twice CdOH twice. So when we are using the battery, then this reaction will follow, and this voltage of the cell is 1.4 volts and it has longer life than the lead storage, but it is more expensive to manufacture. Next we'll be moving to the fuel cell. So it is a galvanic cell in which chemical reaction or the chemical energy from the combustion of fuels like hydrogen, methane, methanol is converted into electrical energy. In this galvanic cells, reactants are continuously supplied to the electrodes which react to produce electricity, and products thus formed are continuously removed from the electrolyte department. One of the most successful fuel cell uses in the reactions of hydrogen with oxygen to form water. It is used in Apollo space programs. So the water vapors produced during the reaction were condensed and added to the drinking water supply for the astronauts. So in this cell, hydrogen and oxygen are supplied through porous carbon electrodes into concentrated aqueous sodium hydroxide solution. Finely divided platinum or palladium is incorporated into these electrodes which act as a catalyst. So the reactions which are happening are O2 plus 2 H2O plus 4 electrons will give rise to 4 OH negative, and at anode we have 2 H2O plus 4 OH negative will give rise to 4 H2O plus 4 electrons. So overall reactions 2 H2O plus O2 will give rise to 2 H2O. This water is produced after the overall reaction. So the advantages of fuel cells: it is highly efficient, that is 70% in comparison to thermal power plants which only give 40% of efficiency. It will not cause any pollution as no harmful products are formed. It is only water which is formed after the overall reaction. And this cell runs as long as we provide hydrogen and oxygen. And this cell, being lightweight, has been used as automobiles on an experimental basis. So in this part we have completed the primary and the secondary batteries in the fuel cell, and we have completed all the batteries part, which are the commercial cells of chapter 2 electrochemistry. Thank you so much for watching. Stay tuned for more updates.